Hello and welcome to another video of Learn with Rangasala. In this series of year separation, we'll continue our topic. Almost simultaneously, this Petic in Geneva, Switzerland also liquefied oxygen by compressing oxygen to 200 bars, then cooling it to 173 Kelvin by the sublimation of dry ice, which in turn had been cooled by the evaporation of sulfuric acid. In both cases, however, a true continuous liquefaction of oxygen was impossible because the critical temperature of the gas is 155 Kelvin. Nevertheless, Pectet point the way to a new route to achieve low temperature, namely the cascade principle, using a series of refrigerant, each lowering the temperature of the next one. This principle was fully developed by Som at Leiden in his work with helium using ammonia evaporator at 239 Kelvin, ethylene at 169 Kelvin, methane at 111 Kelvin, and nitrogen at 77.6 Kelvin. At this point, it is of interest to point out that during the latter part of 19th century, 3 experimental laboratories developed in Europe for the purpose of studying liquefaction, separation, and purification of industrial gases at low temperature. The men who work in these laboratories should be given high credits because they constantly face risks from fire and explosion. Given the limited availability of safety standards and process equipment at that time, it was only in the latter part of the 19th century, for example, the Royal Institution in England decided to use reverse bulb threads in differentiate between inflammable and non-inflammable gases. The Royal Institution of London, England, founded in 1799, intensified its low temperature studies, especially under James Dewar, who developed the Dewar's flask for converging cryogenic liquids. He liquefied hydrogen as well as 1898 in 1890 as well in 1898, a high achievement at that time. In 1882, the University of Leiden, Holland, hired Ons as professor of experimental physics. During his tenure, once a close friend of van der Waals, founded the cryogenic laboratory in order to study equation of state isotherm theorem, isothermal and general thermodynamics properties of cryogenics liquid and gases. He became a master experimenter of physics. His laboratory included the development of measuring instruments and the fabrication of material for his experimental work. Postgraduate students worldwide were eager to intern at his laboratory. It was in 1908 the once succeeded in liquefying helium at below 5 Kelvin. He also observed superconductivity at 4.19 Kelvin. He was unable to solidify helium. However, this latter phase was accomplished by his successor Kempson in 1926. Kempson then refined the On's data on specific heat and discovered that at 2.2 Kelvin another type of liquid was found, which was named helium-2, and it exhibited a small smaller density, a greater latent heat of vapor, and a smaller surface tension. In other words, super fluidity. Another smaller but important cryogenic laboratory was founded at the Jagiellonian, Poland, around 1876, under the team of this thing, a very strong theoretician, and Carlo, a capable technologist with a doctorate degree. In 1883, they liquefied air, carbon monoxide, nitrogen, and finally oxygen. In fact, with the extraction of hydrogen, they liquefied and studied the properties of all the known gases. They also improved the cascade principle that Pixtet had pioneered. In January 1884, Bonn produced a continuously changing liquid of hydrogen by cooling the gas with liquid oxygen and allowing it to expand rapidly, at most dangerous experiment by modern standard. In 1885, he also reported a change of conductivity in copper at low temperature. Unfortunately, in 1914, an invading army closes down the promising laboratory. We'll learn thermodynamics in next class. Thank you for watching. See you in another video. Bye bye. Take care.